Buenas tardes, good afternoon. Well, I'm not a public speaker. I'm always on the backstage, but I feel more comfortable with the microphone because it's like I'm on Teams, so I'll just think that I'm behind a screen. Basically, I'm a CTO at Aire. We do many things, but majorly, the most important thing for you is that we are a cloud provider. We do managed services and cybersecurity, and we're hosting, well, many projects from different agencies, like they mentioned, that they're hosted with us, and they rely on our expertise to make sure that they run smoothly. All right. So this afternoon, I'm talking about a topic that probably is a bit out of context because most of you are developers and don't run infrastructure. But I believe that this is really important to know that all the code that you develop is running on top of a system. And if the system doesn't run smoothly, everything can go downstream, and clients will not buy any of the solutions. All right. So the topic is high developable systems fail spectacularly. We all know that at some point somebody has callers at 3 a.m. in the morning. You get a cold sweat behind your head, and you're ready to die. So basically, this will be me at night. So everything always fails on the worst day. It can be a Black Friday, peak traffic time, and a total flat line. The flat line is not the income, because the income goes down. The flat line is my heart going numb, So basically, usually it's not because of the infrastructure has not been well scaled. It's not because the volume of traffic is too high, or because it's a poor planning, or planning on the obvious places, all right? Sometimes, like in this time, the culprit, it was how the images were handled on the back end, because somebody implemented a sequence that it was requesting the images behind the system. It was following the same path, and they were trying to resize them all the time. So it was in a loop, and everything was generating big traffic on the IOPS on the data stores. So the front end servers, they weren't slow, they were just waiting for an answer, but nobody was giving them an answer. And all the systems, even if they were on high availability systems with many front ends, many active SQL clusters, they were just waiting. They were overloaded because they were queuing the processes. So in here you can see a small graph, like people, they think sometimes it's just an image. I will request it to the system, and it will be brought back to me like a simple thing. But in reality, depends how it is designed, the system. It can generate a lot of traffic on the back stages. And in here, you can see on this graph that, well, you can actually see the measurements. But before Black Friday, this was how the IOPS systems were running, was really high. And it was right on the limit of what the system could handle for the type of system. And this, what did is that the system went completely down right on the time when shops opened for Black Friday. And we had to invent something at some point, reconfiguring like reverse proxies. So the traffic will enter the system slowly, and basically was serving the traffic little by little. But on the following days, we talked with different developers, and this is one of the things that we like to do. We're system administrators, but we're mainly people that like to speak the same language with like developers, and we can understand each other and merge all the systems, because if we can have the best infrastructure and you can have the best code, but if we can't talk together when there is an issue, probably we're throwing stones one to each other, and nothing runs. And in the end of the day, the client is who is paying the price. So when we talked to each other afterwards, and we had some hard meetings. No, I'm not going to say the less, but you can see that the graphs decrease completely. And that is something that was missed before the stages, and probably is something that we could have avoided, but well, it was that. Different example, the 500 error that is that famous and we never want to see. We have a different client that somebody decided to implement an integration with Instagram on the home page of their e-commerce, and suddenly, yes, it was an infrastructure issue, well, it was a network routing issue, but that impacted the website. But impacted the website because actually the server couldn't connect to Instagram API, all right? But the home page or main system shouldn't get to hold because you can access a social media API. That is, for me, it was a bug within the system, but that collapsed a whole system. All right, this is a client where they had a high availability system, really expensive. They pay big money every month for the service, but just a small thing didn't cover that outage. And sometimes you can have the biggest system, the more complex system, but when it's the most important time, it's useless. All right, so what I'm saying is that complexity is great. We're all engineers. We like to play with different tools, different languages, and on our free time, even on business time, we'd like to experiment. Is within our nature, all right? But for business, that can be our Achilles heel, all right? So before I've always been an engineer. Right now I'm a CTO, and for me as a CTO, complexity is a liability, and mainly for business, and definitely for the client. So every technical decision that we make, it's a trade-off. We're all familiar with caching, external APIs, distributed system, and when we try to implement each one, so it can be like performance versus consistency, features versus reliability, scalability versus complexity. We need to think if that is what the client actually needs, all right? Sometimes we think too much ahead, and maybe it's not what the client actually needs. We know what the client wants because they tell us that, but maybe he doesn't know what he actually needs, and we don't need to try to understand or find out that need through conversation and develop or create what he actually needs and provides value to him. So every dependency, it adds like an API call, a shared resource, and test assumption. It can be it creates a downtime that is not a technical debt, it's a business debt. All right, everything is money. We know that all the clients they don't want to pay money for the systems. They want the cheapest system. It's hard to sell the development of the site, but it's even harder to sell the infrastructure needed for that site, all right? So if we provide to the clients a high available system that is really expensive, but when it's most needed, like a Black Friday, it falls down, nobody will want to buy that solution. So mainly technology serves business, not the other way around. Sometimes it's hard, like engineers, to think that way. We need to all understand the cost. Every architectural choices carries business price tags. We need to make it visible. Talk with the stakeholders, with the clients, everyone, to understand what we actually need and the cost that they will have, and to test what we implement in real world. I encourage you to implement a stress test to the systems before you deploy it to production, and to make sure that on the right day, like a Black Friday, your system can actually carry that weight of load, all right? And design for failure. We usually design for the systems that we would like to have, and we think is the best thing for the client. but we need to think on the failures that this system can have. All right? So always think if that complexity is needed or is not. My lemma is keep it simple. You know, we all know the term of KISS, keep it stupid simple, or simple stupid, sorry. But sometimes I believe that we forget that. We forget that we're within a business and all we do is for the benefits of a client, and we need to work towards that. So the main takeaways is small things can break big systems. Let's think about that. Accidental dependencies are the more dangerous. Somebody implements something, says, well, it will do for now. You forget about it because we do many, many things, and it stays in there on the background until the day it explodes, and we have that much complexity and that many systems around that when is the most important time to debug the system, we don't get it on time. We're on pressure. So complexity is a liability that we choose. Sometimes we don't think about it, but we actually choose it on the moment. And engineering and business must speak the same language. I believe that it is hard. As a CTO, I had to learn it, but we need to speak the same language than the client, and at least we get to know what they actually need in the end of the day. So it was a short talk. Thank you very much, and we can meet afterwards if you have any doubt.